Most people are unaware of NAT. NAT is an abbreviation. It stands for Network Address Translation. NAT actually saved the internet back in the early 90s. Without NAT, this great idea of having a vast network connecting computers around the world may have ended before it really got started. In the early 90s, after the expansion and commercialization of this once research network, which we now call the internet, the future was uncertain because the commercialization of the internet caused a very high demand for new IP addresses. New IP addresses were estimated to be totally exhausted by 1995, ending internet growth before it really got started. There were no such thing as private IP addresses back then. Public IP addresses were used for both public and private networks. As shown here in this diagram, we have 8 computers connected to a hub. We used hubs back then, not switches. This is before switches became popular. And we also have a gateway going to the router connected to the hub. What you notice is that all of the computers plus the gateway all use public IP addresses. This excessive use of public IP addresses were leading to a depletion of new IP addresses and an early end to the development of the internet. To save the internet, the first decision made was to use private IP addresses on private networks and continue to use public IP addresses on public networks. Today, we have 2 groups of IP addresses, public and private. The decision to use private IP addresses on private networks led to the development of NAT, which stands for Network Address Translation. I'll explain this further. Now, once a decision was made to split the IP addresses on the internet into private and public IP addresses, they also made a decision to make a private range in every class. So we have class A range, class B range, and class C. Now I'm using class C range for this private network. Now we have 192.168.0.2 right up to 0.8 and 0.9 for the router's gateway, and they're all connected back to the switch here. Now I went ahead and made a second private network on this side with identical IP addresses. I did this deliberately just to show you that private IP addresses can be reused in an unlimited number of private networks. There's no limit. You can have 1,000 networks with these private IP addresses being reused, and it would not be a problem. And the reason for that is because the ISP's router blocks private IP addresses from getting on the network. So these IP addresses are not routable on the internet. So because they're not routable on the internet, these networks are completely isolated from each other. Now if I had a public IP address here, these public IP addresses would be routable, so you can only use them once. If you reuse a public IP address on this network and reusing it on this side as well, you would experience IP conflicts on the network. That's why we use private IP addresses, because they're not routable. So we solve one half of the problem by making the local area networks private. We still have to solve another part of the problem with NAT. So I'll explain that to you next. As a result of having public IP addresses on a public network and private IP addresses on a private network, we have 2 networks that work fine alone, but unfortunately they're not able to connect to each other because, as I said before, private IP addresses are blocked by the ISP. Let's assume that this computer here on the local area network wants to send data to google.com. This is the IP address for this computer, and this is the IP address of google.com over here. Now the user here would bring up a browser and type google.com and hit enter. Once that is done, the computer would generate a packet, and this is what the packet looks like. You have the data that is being sent to google.com right here, and we have the source IP address, which is this IP address for the computer right in here. The destination IP is a Google IP address right here. Now once that is done, this packet would be sent to the border router, and we have NAT in the border router. Well, what NAT would do is to look at the source IP address, which is this IP. NAT knows that private IP addresses are not allowed onto the internet. So NAT would change this source IP address to this public IP address here, which is for this interface number 2 here. This is the public IP that talks to the ISP's router. So it would place this public IP address as the source IP within the packet. Once this is done, this packet will be sent off to the ISP's router. When the ISP's router receives this packet, it will take a look at the source IP address again. And if this source IP address was not changed from the private IP address, this packet would be blocked right here. So that would be the end of it. However, because this source IP address was changed to the public IP address here of the interface here, this packet would be allowed through all the way to google.com. Now once the data you requested from google.com has been sent back, now it would look like this. This will be the data from google.com. The source IP address will be the google.com IP address, and the destination IP address in here will be this 104.35.43.3. Remember, we had changed from the private IP address as the source IP to this IP. Now this IP address now would become the destination IP, which would be right in here. So when NAT sees this packet, NAT will know that it had taken the private IP address out and put it into storage and replace it with this IP. So now it would do the reverse. It will take this IP address out of the destination IP area and it would replace it with this 192.168.0.2 IP address. Once that is done, this packet will be sent to the computer and the user will see the page from Google displayed on the screen here. If you like this video, please don't forget to click on the like button below. And if you would like to see more videos like this one, but you have not subscribed as yet, please don't forget to click on the subscribe button below so that you'll be alerted as soon as our new videos are released. My name is Trevor from Telecom Training. Thank you for watching.